This video covers different angles of password penetration testing. A penetration test is a method of evaluating the security of a computer system or network by simulating an attack from malicious outsiders. This analysis is carried out from the position of a potential attacker and can involve active exploitation of security vulnerabilities. The video is meant for educational purposes and personal penetration testing only. Remember, unauthorized use of another person's computer is a crime, so don't do it. We'll begin by navigating to the directory where Windows passwords are stored in the C drive, Windows, System32, config directory. Remember, this path name, we'll be using it later. There's two files we're concerned with here, the SAM and the system files. The SAM, or Security Accounts Manager file, is where the Windows lists the username and passwords. The SAM file is encrypted, so even if we were able to open it, it would be unreadable. We need the system key, which is contained here in the system file, to decrypt the SAM file. The kernel keeps a file system lock on both of these files. So while Windows is live, we can't move or copy or really do anything with them. So to access these files, we'll be using a live CD, which is a bootable operating system. You can download Backtrack 5, which is the one we'll be using here. Just click download, it'll give you the ISO, and you can burn it onto a CD. This will allow us to bypass Windows security and privilege restrictions on these files. Although we will be using the live CD, we can still alter the file system's MAC times. The acronym MAC stands for Modify, Access, and Change. So as you can see here, accessed, modified. If we access a file, or if we change the file or its metadata, it will log it. And also, even more information can be pulled from a journal file system. So from a forensic standpoint, if we want to leave no tracks of what we're doing, we need to boot from Backtrack with the no mount option and do a bit-for-bit copy of the drive using the dd command. And we can copy the drive to another hard drive, an exact copy, or we can transfer the hard drive image over the network to another computer using netcat or SSH. And doing this allows us to work with the copy that we made and leaves the original untouched. For this demonstration, though, we won't be making a copy. I'm going to power down now and boot from the Backtrack 5 CD, and while it's rebooting, we'll talk about password hashing. When you create a Windows user account and password, Windows doesn't store the password in plain text. If it was in plain text, we could simply open the SAM file and see a list of the users and their passwords, and that would be way too easy. Instead, a password is hashed, and hashing is simply taking an input, a password in this case, and running it through an algorithm that returns a fixed-sized string. For example, using the MD4 hash function, if I input the words 57 Chevy, or the passphrase, I get the 32-character output that you see in this slide. This is what would be stored in the Windows SAM file. And looking at all three examples, we see that regardless of the input, a 32-character output is created. Notice how changing the lowercase c to an uppercase C completely changes the hash output. A good hash function will not have any hash collisions, which means no two inputs will have the same hash value output. Each value has to be unique. For example, if the words dog and cat had the same hash value output, I'd be able to log into Windows with the password cat even though the password is dog. This is because when I log in, my input is hashed and compared to the stored hash value that Windows has on file. And if they're the same, it assumes that I input the correct password. Hash functions are unidirectional. You can't figure out the input from the hash output. It's a one-way road. However, if you're able to get a list of the Windows password hashes, we can launch what is called a brute force attack. Basically, all we're doing is hashing every possible input and comparing our output to the hash list Windows has. This doesn't take as long as you might think, because even on a dated laptop we can compute and compare millions of hashes per second. In the example on the slide, the lowercase letter a is hashed and compared to the hash value we retrieved from the SAM file. They're not equal, so we move to B, then C, all the way to Z. Then we try uppercase letters, numbers, special characters, combinations of 2, 3, 4, hashing every possible password combination. Eventually we'd hash the word password, which happens to be the password in this case, and we have a match. There are many different types of hash functions. It's important to know which hash function we're using so we can use the same one in our brute force attack. Here are some of the example outputs of other hash functions. Windows 7 uses NTLM, and you can get further information on that hash and its predecessor LM online. Okay, now we have enough background information to begin our demonstration. As we discussed earlier, we'll be using a live CD to bypass Windows security features. If bootable media is disabled in BIOS, you'll need to re-enable it so you can use the CD. And actually, disabling bootable media and creating a BIOS password is one way to slow down a malicious hacker from using a live CD. Although with physical access to your box, the BIOS can be reset by removing the small battery on the motherboard. Okay, use the fdisk command to list all the hard drive partitions. We need to find out where the Windows operating system is installed. It looks like there's only the one option, the dev SDA one, so now we'll make a directory. I'm going to put it in the mount directory and call it win. Then we'll mount the partition to the directory, creating an entrance point to the file system. Now we can cd into Windows, so let's do cd mount win Windows system 32 config, and then we'll list the files. That should look familiar, that path name. Okay, here we have the SAM and the system files. First thing we need to do is bkhive the system file, which will dump the system key that we need to decrypt the SAM. I'm going to put it on the desktop and name it key. You can name it what you want. There you see we dumped it. Now we'll do SAM dump to SAM, point it to the system key so it can decrypt it, and I'm going to put it on the desktop again and name it hash. Now we can cat the hash file and take a look at the list of username and passwords. So now we can begin cracking the passwords here, or we can copy the hash file on a flash drive and take it to another box. But once we have the list, they're as good as cracked. Okay, let's go into the penetration testing directory that's on Backtrack 5. Here you can see that we have a passwords directory among the other options. Let's go to cd passwords ls. Okay, we'll do demonstrations on Hashcat and John, and then we'll talk about OCL Hashcat, rainbow tables, and salt values. So cd into John ls. I'm just going to type John and pipe it to less so we can look at the different options when we run the program. And I'll just go over the minimum we need for the demonstration. So at the bottom we have format and the name. So since we're comparing Windows hash values, we'll select NT. But if we had unshadowed the etc shadow file from a Linux box, we'd probably be using MD5 or another from this list. The option users allows us to focus on just one or a few users instead of our entire list. And we will need to discuss incremental, but there's a better description in the John configuration file, so let's go into that. So I'm going to use VI. You can use whatever text editor you want. VI into the John comp file, page down through all of this. Okay, here we are. So here's the different modes. If you know a password's all numbers, you can set the incremental option to digits. This speeds up the process because you don't have to hash combinations of all 95 ASCII characters. The all mode does do all 95. It's the most time consuming but the most thorough. The alpha option does lowercase letters. Alphanumeric combines lowercase letters and numbers. The landman option takes advantage of the fact that LM hashes converted lowercase letters to uppercase before hashing. That's why the character count is 69 instead of 95, because it doesn't need to bother trying lowercase letters. LM also split the hashes into two 7-byte halves before hashing, so you'll notice the max length is set to 7. LM's very weak and easy to crack, and so you don't see that around much anymore. All but the landman option have default max lengths of 8, so if they use a long password, John won't be able to crack it with these default values. John isn't really the best program available for password cracking. The landman and all mode do have a min length of 0, so they'll catch the guest account if there's no password set. Okay, let's run John with our hash list. We use the format option to specify we're using a Windows NT hash list. The user option allows us to crack just Mary from our list. And the final argument is our hash file. John instantly finds Mary's password because in addition to brute force, John keeps a list of commonly used passwords and tries those hashes first. Seven Dwarfs obviously is a terrible password, so let's try this again. We'll use the incremental mode against the administrator password. So we'll change out Mary to administrator. And -I is short for incremental. It saves some typing time. So I'm running this. I'm hitting enter to show me the progress. It'll tell me the time and the values it's comparing. It took only about 4 seconds to crack this one. Obviously this is a weak password, but it's great for our demonstration because we don't have to sit here for hours. So let's do this again. We'll run it against the entire list. Just take out the users option. Because it checks the null value, it immediately pulls up the guest account. Now I'm hitting enter. Pressing Control-C stops the session. You can see I stopped it at 5 seconds. If you type John restore, it picks up right where it left off. We're at 8 seconds, 9, 10. If you want to learn more about the different options John has, you can check the documentation in the doc directory. Let's check out Hashcat, which is another program for password penetration testing. We'll change directory to the pen test, passwords, Hashcat directory, and list the files. I'm going to run the help option. Pipe it to less. Okay, there's really only two here that we'll use in this demonstration. The attack mode, which we'll be using brute force number 3, and the hash mode will be 1000 for NTLM. So I'm going to run the program. We'll add the attack mode. 3 for brute force, and the hash mode at 1000. And then we'll add the file. Actually, I don't think Hashcat's going to accept that. It wants a file with just the hash. So I'm going to grep James from our hash file that we created earlier. That'll pull just the line James out of that file. And then I'll put it on the desktop and call it single hash. I'm going to use a text editor. So I'm just going to delete everything here except for the actual hash, the 32 character hash value. It doesn't need the username or account information or anything. Okay, write and quit. Okay, now we'll run our single hash against the program. Here's the license agreement, type yes. Okay, so look at this output. Shows us the character set is just lowercase letters that it's trying. So for combinations of 2, there's 676 possible combinations. It tried them almost instantly. With 3, there's a little over 17,000. Still tried all those in less than a second. Combinations of 4, there's about 457,000. Again, in less than a second, it tried all of them. Combinations of 5, there's about 12 million. That still took only about a second. There's about 309 million of combinations of 6, so that'll take about 33 seconds. And combinations of 7, there's about 8 billion, so that'll take about 14 minutes to try all of those. So you can see that length is the key in creating a strong password. Even if you add a period 6 times to the end of your regular password, it'll prevent a quick crack. OCL Hashcat, in comparison to Hashcat, allows you to use up to 16 GPUs or graphics processing units. This will increase the number of your hash values that you can compare per second. I've heard claims that a system with multiple GPUs and processors can run billions of hashes per second. OCL Hashcat is multi-threaded and multi-platform. It has a Windows version, and it's one of the better options for password penetration testing, and it's free, so can't go wrong there. The brute force method's not always that effective, especially if there's a longer or more complex password. Another option we have is a dictionary attack, which uses word lists. And word lists don't have to be huge files because we can use rules to mutate each word in the list into many, many different character combinations. And I think most of us are guilty of capitalizing the first letter of a password to make it seem stronger, but there's rules to cover these common mutations. Another common mutation we use is adding dates or a number to the end of a word. So to illustrate an example regarding the word list rules, a word is taken from the word list, say airplane, and we check that hash alone. Then we try airplane with a capital A, and then airplane 1900, airplane 1901, 1902, and so on. And also the rules are dynamic that changes the words. So as we discover new passwords from our list of hash values, our rules that manipulate the dictionary list can change, and this can happen manually or automatically. That's why it's so dangerous for companies to have a set password policy. If a group of employees is required to have a set password type, say a special character followed by 3 numbers, then 4 letters, then as soon as one password's cracked, then the word list rules change and they try all combinations that are similar to the cracked password that we already have. Okay, back to Windows. We have one more concept to discuss before we wrap everything up. Of all the options that we have for cracking Windows hashes, using rainbow tables is by far the quickest. A rainbow table is a pre-computed table of hashes. It's a database, and the hashes in the table are organized so they can be quickly searched. Rainbow tables take time to create, and they take up a relatively large amount of hard disk space, but hard disk space is pretty cheap these days. Once complete though, you can search for any hash value and get almost instant results. So each rainbow table has to be specific. If you have an MD5 rainbow table, it's not going to help you with Windows NT passwords. And you can get these at one of the websites. It's convenient. It's freerainbowtables.com here. And if you go to the Tables tab, you can see here's the NTLM, the Windows password hash. Here's a 430 gigabyte file for password lengths 1 to 8, and it uses these characters here. Up here in the Downloads tab, these are the tools that you'll need. You can download one of these to use with the table. The downside of rainbow tables is they can't be used if a salt value is used in the hash creation. Salting is just adding extra bits to the password before hashing it. So instead of one input on the hash function, you have two. You have the password plus the added bits from the salt value, which are random. So you can have two users with the same password, and they're going to have different hash values. And this makes rainbow tables useless because you'd have to make a rainbow table for each random salt value. So it forces us to crack one hash at a time. Fortunately, Windows doesn't use salt values, so it's super easy to crack 99% of the passwords out there. If someone gets a hold of a Windows password with administrator privileges, they can install a number of programs to get other passwords off the computer. And Nearsoft.net provides a bunch of different options here. There's programs to recover the passwords for instant messaging, for email, all of your web browsers, Internet Explorer, Firefox, Google, Chrome, Opera. When you tell your web browser to remember a website's password, like Facebook, Amazon, eBay, any of that, your email, the passwords are stored on your drive, and these programs just pull it right off with no problem. They can get wireless network keys. There's all sorts of things they can do with this. So knowing how easy it is to gain access to your box and to all of your passwords that you put in can keep you on the defense. And here's a few tricks you can use to secure your information.